This is again a video on lossless data compression. It is based on the following idea. And we know if we have any binary number, the weights must always double. The next weight, the next leading weight must be twice the previous weight. This condition must always be invariant. Now our objective is to map a number m which is less than 2 power l dash to a value within S which is equal to 2 power L, where L dash is very much larger than L. Now this form of coding is based on the idea of using L as the base to map to L dash and assigning the weights. So in this case what we do is we determine X such that L power X is equal to 2 power L dash. So this gives us X is equal to L dash by log L. Where this is Lg equal to log to the base 2 of L. Okay. Now the weights we map are, the weights we assign are successively L power X minus L minus 1 power X, comma L minus 1 power X minus L minus 2 power X, comma, and so on. L minus 2 power X minus L minus 3 power X, and so on up to 2 power X minus 1 power X, comma 1 power X minus 0 power. X. So these are the weights we assign to the L bits in order to code L dash bits. Okay. Now since we want the invariant condition to be maintained, therefore we require L power X minus L minus 1 power X must be equal to 2 times L minus 1 power X minus L minus 2 power X to roughly hold good. In other words, we require L minus 1 whole power x minus 1 should be nearly equal to 2 times L minus 2 whole power x minus L minus 2 whole power x minus 1. In other words, we require L minus 1 by L minus 2 nearly equal to 2 power 1 by x minus 1. Right? In other words, we require one by x minus 1 is nearly equal to log of binary log of L minus 1 by L minus 2, or x minus 1 nearly equal to 1 by binary log of L minus 1 by L minus 2, or x, I will say more or less equal to 1 plus 1 by log of L minus 1 by L minus 2. Now we know that x is nothing but L dash by log L. So this gives us L dash by log L should be equal to 1 plus 1 by binary log of L minus 1 by L minus 2, or L dash is equal to log of L times 1 plus 1 by log of L minus 1 by L minus 2. So we can assume a value L dash. If for a given value of L, we can compute L dash. If we fix the length L, say assume the size of a block of a file or something like that, those L bits we wish to assign the weights. If we assume for instance, if we assume that the size of a block is 2 power 12 bytes, that is equal to 2 power 15 bits. L dash, the ratio of L dash to L comes out to be roughly 10.5 something, or roughly around 10 times the ratio. So you will get a slightly, as the number of bits you take increases, the number of bits you can code also using this method of distributing weights while ensuring that the invariant is maintained. So it should give decent compression, fairly high order compression, lossless compression.